Hello, everybody. This is Mr. Hennon, and here we are going to take a look at how do we go about solving a kinematic two-dimensional projectile motion problem when we have it launched at an angle. So instead of just moving horizontally, it's actually going to be launched at an angle. So in this particular case, I think it's easiest to just start off with an example. So what I'm going to try to figure out from this problem is what is the height of this kickoff? So we have our place kicker is going to kick our football at an angle of 40 degrees, and they're going to give it an initial speed of 22 meters per second. We're going to try to figure out what's the maximum height that this ball attains. So we're going to try to find this information right here that they have us figuring this out. Now, what makes this different is we have the initial velocity here. They call it V0. I like to call it VI. But really what we need to do is we need to figure out how fast this thing is moving vertically and how fast this thing is moving horizontally. That's the information we actually need to go with. So the first thing we're going to do is we're going to actually have to break this up. So this part of the equation is this is 22 meters per second. And this is 40 degrees. So yes, we get to go back to trig, yay! And what we're going to try to do is find the components of this velocity. So what I did is instead of leaving my VIY over here, which is actually where it's coming from, because this is my football right here, I moved this so it's over on this side, and so that we actually have it here, so it's easier. Plus, it forms a nice little right triangle that we can kind of work with. So the idea is we're going to try to find the opposite side and the adjacent side of our angle. Now, the reason I write this as VIY, but this one is just plain VX, is remember that VX works because VIX and VFX are the same, so we just call it VX. We don't have to put an I on there. If you want to, you can. So the easiest is if I pull out good old SOHCAHTOA, then what we remember is that SO is going to deal with opposite and hypotenuse, and CA is going to deal with the adjacent hypotenuse. I would not actually use TOA in this case, so we're not going to use this. We're going to start off with sine. So it tells us that the sine of our angle should be the opposite side. So the opposite to the angle is actually VIY divided by the hypotenuse, which is just plain VI. Now, I get a lot of people to look at this and they're like, don't the VI's cancel and this would just be Y? Remember that Y is a subscript, so this is saying a different kind of velocity. In essence, what we end up with is that if I multiply this VI over here, we should be able to find VIY. And so VIY down here is going to be equal to the initial velocity multiplied by the sine of our angle. This should sound familiar because we did this when we were trying to find vertical displacements. Now we're just doing it with velocities instead. So I can plug in my two numbers. I can plug in my 22. I can plug in the sine of 40 degrees. And sure enough, I'll have the initial velocity in the vertical direction. I'll have VIY. So I'm going to grab my handy dandy calculator and take 22 times the sine of 40. Make sure your calculator is in degree mode. Otherwise, you're going to get a funny answer on this one. And I get that this is 14.1413. I'm just keeping a couple extra numbers, meters per second. So what this tells me is when they kick the football at 22 meters per second, it's actually moving upward at this 14.14. That's in essence what it's doing. That's a component of it. That's a portion of that actual velocity. So let's change. Let's move into x instead. So this one I'm going to actually use cosine. So the cosine of my angle should equal VIX over VI. So that's going to rearrange and give me VIX is equal to VI times the cosine of my angle. And these are actually a couple of good equations to have. This is a good one. This is a good one. These are actually ways of finding your initial velocity in terms of the sine and cosine, in terms of the angles and the diagonal. So breaking them up into horizontal and vertical. So for this one, we're going to take 22 and multiply by the cosine of 40 degrees. I've got that saved here on my calculator. So I'm just going to do that, change this into cosine, and I get 16.853. 16.853 meters per second. So if you're ever faced with a velocity at a particular angle, it's always going to be good to break it up into the horizontal part. How fast is this thing moving horizontally? And a vertical part. How fast is this thing moving vertically? So we can actually work with it. Now I'm ready to actually solve this problem. Since I'm dealing with a maximum height, really this is a fancy way of saying I'm trying to find y. So this is what I'm after. Do I know what g is? You bet. I know that g is 9.8 meters per second squared. Notice I am not putting the negative on there because all of our equations just have 9.8. Do I know the VFY? If this is going to be the maximum height, we know it's going to take off with some velocity in the vertical direction. But as this football travels along this path, the cool part is its vertical velocity is going to get smaller because gravity is slowing it down. So it's not going to be moving up nearly as fast here as it was way down here when he first kicked it, or even right here where he kicks it. So it's going to be a little bit smaller. And then when it gets a little bit higher, it's going to be a little bit smaller. And as it gets higher, and so when it's right at the highest point, we've actually done this already. What would be that vertical velocity? Its velocity in the y direction would actually be 0 right here. So if we're going to that maximum height, we can actually use the fact that this is 0. Since we're going to that maximum height. What's the initial vertical velocity? That's the VIY. The most common mistake is people want to put that 22 in here, but don't put that 22 in. You want to put this 14.1413. That was what we came up with. So that's what I'm going to put in here. 13 meters per second. And I don't know what time is. But my hope is I don't need that. I'm going to find that maybe later, but right now I don't need that. So do I have any equations that have VIY, VFY, G, and Y in them? And you bet I do. I have this main equation that VFY squared equals VIY squared minus 2 times G times Y. Since I'm trying to find Y, I would rearrange this. Basically what I would do is I would subtract this over to the other side. So I would subtract it. That's going to give me VFY squared minus VIY squared divided by, and then once I have subtracted that over, then I want to get rid of this. So I would actually divide by that number. So minus 2 times G. And this should allow me to find Y. Now my VFY was 0. So this part's just going to become 0. My VIY was that 1413 meters per second. So I'll plug that in there. My G is 9.8 meters per second squared. Plug that in there. So to find Y, it's actually going to be 0 minus, I'm going to be taking this 14.1413. I actually have the full answer kind of written down. Now realize it's 0 minus that. So it's not this negative number squared. It's actually still going to be negative. That's good because on the bottom I've got negative 2 times my 9.8. So basically what's going to happen is these negatives are going to become positive. So really what I'm doing is I'm taking the velocity squared divided by 2 times my acceleration of gravity. So I've got that velocity already saved. I'm going to take that. I'm going to square it. And then divide by, make sure I put parentheses around this. I would actually put parentheses around the whole thing so that I'm taking 2 times 9.8, or if you want to, just realize that's 19.6 when you do that. And chunk, I get that Y, the maximum height of this football, is going to be 10.2 meters. So this football is going to go 10.2 meters up. Ta-da, we just found the height of this thing based off of a velocity and an angle. And really what we found is the maximum height that it has from wherever we kick it. I'm going to do a lot of stuff where I'm going to assume it's on the ground, so I'm finding the maximum height all the way up, but we could kind of realize That's what we're dealing with. Notice I didn't actually use anything with my horizontal right now because I don't actually care about the horizontal because I wasn't doing anything horizontally. I was only doing things vertically. My little box here only dealt with vertical. I also didn't find the time because I didn't really care what it was. So I'm going to leave you with this problem. We know that a fire hose ejects water. And if you're trying to hit some point up on the building, you're trying to go to the maximum height. So if you're trying to go to the maximum height, you have the water coming out at a certain speed, 25 meters per second. Let's say you tilt this at 35 degrees to hit that fire. What I want to know is what's the highest the fire you can hit, or in other words, what's the highest the water will actually go. So this is the same kind of problem. I want you to try to see if you can solve that. And when we meet next time, we will actually go over that sample problem so that we have that. Hope you enjoyed this edition of the Henstitute on projectile motions and finding maximum height.